Test 0, lockdown browser checked. Everyone's got a way to submit a PDF. Yes, there's no issues there with anyone.
Yeah, everything's fine.
Is Alex? Alex is not here yet. Good. All right, so the first couple of questions are from Sean, and they're perfect because there's something like each of these on your exam. So the first one is, I'm giving you a rational function. So it doesn't matter what problem number this is or where it's from, because, right, this is rational functions. And there's a bunch of problems about rational functions that Sean sent. Except for an inequality, make sure you do one of those sign table ones, right? So I've got my function f of x equals x cubed minus 8.
Professor, I think you're not hearing.
Thank you. Wake up, Robert. Here we go, right? So I've got x cubed minus 8 over x squared minus 81. Now, what am I going to ask you to do? I'm going to ask you to give me everything for this curve, everything what we've done, right? Standard form, done. Factored form, almost will be done in a minute. Reduced form, right? Domain, possibly range, most likely not range, possibly range. Horizontal asymptote, vertical asymptote, obliques. I'm not planning on putting an oblique on the test, right? On Hell asked me to do another one today. I'll do another one today. I don't think I'm putting an oblique on the test. Intercepts, x and y intercepts, short run behavior, right? Anything that I want, right? Everything that I want. And I'm going to prompt you for everything I want, okay? So this one is just asking me to write this in, this is standard form, right? But they also want me to write it in factored form. So I can see downstairs right away, I've got an x plus 9 and an x minus 9. And upstairs, if I don't see it, I can graph the upstairs, right? I can graph y equals x cubed minus 8 on my calculator. And I'll see that it goes through 2. So I know 2 is a 0, and how am I going to find the other piece of it? Either I have it memorized from Algebra 2, or I synthetic divide. I'd rather synthetic divide, honestly, than memorize anything. So 1x cubed, 0x squared, 0x minus 8. Right? So bring down the 1, multiply, add, oops, multiply, add, multiply, add. So it is a 0, and I could see my reduced equation is x squared plus 2x plus 4. And there it is. There's my factored form and my reduced form.
Is there a difference between factor and reduced form?
In this particular case, nothing cancels, so they're the same. But if I had a matching factor, which would give me a hole in the graph, or what we call a removable discontinuity, that would be my reduced form. But I have to adopt the domain from here, right? And what is the domain of f here? What is the domain?
X is not 9 or equal, or minus 9.
Exactly. Right? And usually the book will, so I don't care how you give it to me if I ask for a domain, but like MathExcel will ask for an interval, right? It's from minus infinity to negative 9, union from negative 9 to 9, union 9 to infinity. So kind of seeing a number line with a hole at negative 9 and a hole at 9, right? Those two places I can't put those x values in. I can't walk on that axis. I would fall through at those points. Sean, what's up?
What's the what are the three the negative infinity, -9, -9? What is that the?
Those are the intervals. So if you imagine my number line on my desk, right, in like second grade, you can see at -9 I've got a hole in the graph, so I can't use -9. So I can use anything over here. I can walk over here. I can use any number I want, like negative 10 billion. I can put that in the function, no problem. I can stand on this piece. So I'm saying there's a hole in the ground at negative 9 and 9, but everywhere else I can walk, and this is what I'm telling you where I can walk. What x's I can use. So for example, can I use x as 3? Can I use x as 3? Well, yes, 3's there, and that's no problem. Put the 3 in the function, it works. Can I use x as 21? Yes, no problem. So the interval's telling me which x values I can use. I think the picture makes the interval look a lot easier to understand, right? The picture makes the interval, the number line picture makes the interval make sense. Anything to the left of negative 9, anything between negative 9 and 9, anything to the right of 9. And that's what this says, right? That's what my interval says.
Do we have to list the intervals on the test, or?
Well, I would like you to show off. So
Okay.
Do what you want to do. Do what you want to do, and then I'll do what I want to do, right? Yeah. I can tell you don't like the interval, but we've been doing intervals all semester. But so think about it a little bit. It's not as complicated as it initially seems. The next one is the graph of the function. I've got x squared of irrational over x squared plus x minus 20. So similar problem, but here we're going to do all of those things. So that's my standard form. What's my factored form? Who's got it? Who can just look at that and factor that for me? It should be pretty easy for you. I'm just looking for the integers that multiply to negative 20 and add to 1, right? Right? Yes, you with me? I'm looking for the integers that multiply to negative 20 and add to positive 1.
Yeah.
Yep. What's my domain?
X is not
equal negative 5 and 4.
Right. X does not equal negative 5, positive 4, right? Of course, the interval there is what? Minus infinity to negative 5, union from negative 5 to 4, union from 4 to infinity. I could also state it as all of the reals minus negative 5 and 4, right? All of those things basically say the same thing. What about intercepts? Well, how do I find an x-intercept? Right, I find where the numerator equals 0. How do I find the y-intercept? I let x be 0. In both cases, they're the same point. So there's only one x-intercept and there's only one y-intercept, and they're the same. Where's my vertical asymptotes?
It's 5 minus 4.
Other way, yeah, x equals negative 5.
Right.
Right, x equals 4. What's my horizontal asymptote? Long run behavior.
Y equals 0?
Nope, 1.
1.
Yep. So f of x is approximately equal to x squared over x squared plus x minus 20, which would just be x squared over x squared, deleting, right, the mother function of the numerator and denominator, right, as x goes to plus or minus infinity. Let's see, what else do we need? Short run let's say short run at 4. So I'm going to use my factored form. I'm going to use my factored form to get f of 4. So I have, where's my factored form? Oh, there it is. 4 squared over 4 plus 5 times x minus 4. So 16 over 9 times 1 over x minus 4. So I can see the mother function, right? So f of x looks like 1 over x at x equals 4. That's my short run behavior. And now I'm ready to graph. And remember, you're going to be graphing this on your calculator first, right? But here's my XY axis. Why'd you use 4? So I'm going to prompt you for where I want the short run, Alejandra. But it's going to be in one of those pieces of the domain that's missing. I would only ask for a short run. Well, what's the short run at 0? It's 0, 0, right? It's boring. But the short run at a vertical asymptote is interesting. But I'm a nerd. So 1, 2, 3, 4, 1, 2, 3, 4, 5, right? So I know at each of those I have a vertical asymptote. Those are uncrossables. At 1, I have a horizontal asymptote that is crossable, right? This is my y-axis, my x-axis. I have the point 0, 0, right? So I kind of have regions here that I know my graph could exist in. So at 4, it should look like 1 over x. So I've got like this new origin over here. There's like a new origin over here. And I know my function is doing something that looks like 1 over x. So something like this and something like this. So I'm looking really close to the line x equals 4. And I know I should have that upward piece of 1 over x and that downward piece of 1 over x. And I'm pretty sure the rest of the graph looks something like this. But again, you're going to have the graph there to verify.
How did you get the intercepts again?
So to get a y-intercept, you let x be 0. To get an x-intercept, you let the numerator be 0. And in this case, they're the same result.
And how'd you get horizontal asymptotes again? Is that just the generalized
long-run behavior? Exactly. Let the mother functions take over and see what you have left.
And is it the same? What do you do for vertical asymptotes again?
It's where the denominator is 0 and the numerator is not 0.
Gotcha.
So the short run behavior is 1 over x at x equals 4.
Yeah, well, it looks like 1 over x. You can see the mother function is 1 over x.
Yeah.
I mean, it's stretched out, right? It's 16 over 9 times that. So it's stretched out, by a scale factor more than 1. But who cares, really? I don't care that much. I want to be able to see, right? I know what 1 over x looks like. Everyone should, right? So I'm just shifting this origin over to here, over to where my horizontal and vertical meet. And then I should see that kind of 1 over x, right, piece. It's like that one. It's hard to do that. Nice. A question just like that on your test.
Professor, for this graph, is that y is equal to 1 or 0?
Oh, yes. Thank you. Y equal 1. Thank you. Horizontal asymptote, right? Yep. Just double checking again, everyone has test 0 finished. Their lockdown browser is working, and everyone has a way to send me a PDF quickly, right? Some of you, whichever way you're sending the PDF is very large. It's a very large file, so you want to maybe really consider using Cam Scanner. It will reduce your file. All right, one more here on rationals from Sean. And this one's just the domain, right? So this is it's okay to look at this because we've already done, right? So f of x is 9 times x squared minus x minus 42 all over 10 times x squared minus 49. So I should be able to factor this pretty damn quickly. Who's got the numerator for me?
6 and 7.
Nice. Minus 7 and plus 6.
Yeah.
Yeah. And downstairs is x plus 7, x minus 7. So you can see I do have a reduced form, right? Of 9 times x plus 6 over 10 times x plus 7. So there's my reduced form. But I need to make sure I still have the same domain, right? The domain is x does not equal plus or minus 7, even though that minus 7 factor cancels. But what's going to happen there is I'm going to have a hole in the graph, right? At x, sorry. Sure, Grace. Yes, I can definitely graph that last one on the calculator. And whenever I'm having trouble using my calculator, I just will Google graphing rational function TI-80, whatever I have, TI-83, 84, or whatever, right? So at x equals 7, right, there is a hole. And it's f of 7 using my reduced version. So 9 times 13 over 10 times 14, whatever that is. That doesn't reduce anymore, does it? No. So 9 times 13 is 117 and 1 over 140. So there's a hole in the graph, right, at 7, 117 over 140. At x equals negative 7, there is a vertical asymptote of x equals negative 7. Sean, okay, on all of those, except for the interval, notation. Am I right? Sean, you okay?
Yeah. How'd you get the hole again? I'm sorry.
So I noticed that these two guys are going to cancel.
Okay.
And whenever that happens, there's a removable discontinuity. There's a hole in the road, but I can patch it. In calculus, I learned how to patch it with a manhole cover. You know, and I'm just talking like a normal human. It's called a removable discontinuity. It's a place that we can put a little concrete down to make it safe to walk on. Going back one problem for Grace, let's go into the calculator here and graph this. So I want to graph y equals x squared divided by x squared plus x minus 20. I'm trying to use my standard form and wrapping multi-terms, right? So I'm using my standard form and I'm wrapping multi-terms. So I'm going to use my TI-84 here. And Grace, don't let me go too fast here. I hit y equal. I go to x squared divided by, open paren, x squared, what was it, plus x?
It was, yeah.
Yeah, minus 20. Close paren. And then I'm going to just graph, and for me, whenever I open my calculator, it reverts back to Zoom standard. But I will give you something that it will look decent on Zoom standard. So again, I hit Zoom 6, and that's Zoom standard, just meaning minus 10 to 10 on both the x and y axis. Minus 10 to 10, minus 10 to 10. Grace, is that helpful?
Yes, thank you.
Yeah. Alejandro, you could send me something else too. Right now, I don't care if I review the whole class period. I don't care at all. We're ahead of the game. We're going to get everything done. We're going to have a week of review for the final exam. Right now, the way we're moving, and I'm not trying to go fast, but there's a lot of material, right? There's no stopping. Okay, so now I've got one from Diego, then Angel, then Michelle, and then Alejandro's going to send me something, right? And that should got it, Alejandro. Thank you.
How about the vertical asymptotes and the horizontal for the previous problem? The 9.
For this one right here?
Or, no, the next one.
Yes. So verticals, there's only one, right? At x equals minus 7.
Yeah.
Because that's the only time my denominator equals 0, but my numerator doesn't. And that's what I need for a vertical asymptote. So when factors cancel, I'll have a hole, a removable discontinuity. And when they don't cancel, I'll have these vertical asymptotes. And what was the other thing you asked for, horizontal asymptote?
That's the, is it the 9 divided by 10?
Yeah, exactly.
Right?
Exactly.
Okay. So it's 9 divided, okay, 9 over 10.
F of x is approximately 9x squared over 10x squared, which is 9 over 10, as x goes to plus or minus infinity, right? As x gets really, really large, it behaves like the mother function. Thinking about minus infinity, but remember, I'm doing x squared, right? I'm doing an x squared, so it's going to behave the same way when I go to minus infinity. So the ha is y equals 9/10. The horizontal asymptote.
And then the intercepts, I think it's 0, 0.
So intercepts are going to come from, let x be 0 for the y-intercept. Let the numerator be 0 for the x-intercept. So I'm going to have a -6, 0 for my x-intercept, and I'm going to have 54/70 for my y-intercept. Again, I let x be 0 for my y-intercept. I let the numerator be 0 for my x-intercept, or intercepts.
Wait, how'd she get 0 and 54/70 again?
F of 0 is 9 times 0 plus 6 over 10 times 0 plus 7. Yep.
Okay, alright.
So better would have been, what, 27 over 35? Right, because they're both even. They reduce. Nice. So this one is from Diego, and it's asking me, use the rational zeros theorem to find the real zeros of this polynomial, right? So that's good because I'm going to ask you one just like this. So great question, okay? So f of x equals 7x cubed minus x squared plus 7x minus 1. And I look at the graph, okay? I look at the graph and I see something like this. And I'm confused, right? It's not obvious where that zero is. But if I look at the rational zeros, right? So possible rational roots, roots, right, is plus or minus the factors of 1, the constant, over the plus or minus factors of the leading coefficient, which is prime, so only 1 and 7. So my only options are plus or minus 1 or plus or minus 1/7. And it should be obvious it's not 1, it's definitely not negative 1, right? And it's on the positive side, at least I think it is. Yeah.
Wait, how'd you do that one more time?
What? How did I do what?
The possible rational roots,
Yes,
1 over 1
factors,
and 7.
factors of the constant divided by factors of the leading coefficient.
Gotcha.
Yeah. And so I think it's 1/7, so I'll double check with 1/7. That's the one that seems to make the most sense. So I got a 7, a negative 1, a 7, a negative 1. I bring down the 7, I multiply, I get 1. I'm sorry, I bring down the 7, I multiply, I get 1, I add, I get 0. I multiply, I add, I get 7. I multiply, I get, yes. So there it is a 0. So I am expecting you to be able to tell me the possible rational roots. Alejandro, I'm just reading, you said what's 117 over 140? Where is that? Was that on a previous problem? Or is that on the problem that you sent? Oh, this is the height. This is the y coordinate of the hole in the graph. The y coordinate of the hole in the graph. Diego, does that help? You okay there?
Yeah, I'm following. I'm just copying now.
Yep. And so you want to, you remember, you have a formula sheet that you're making yourself, right? And you can put anything you want on the formula sheet, front and back. I personally would make 8 to 12 pages of it, scan it as a PDF, and then when you print your PDF, you can print 4 to 6 pages per side, right? So I will allow a magnifying glass on the test as well, if you want to, right, do that. You can listen to music, right? Okay, I got one from Angel, one from Michelle, and then one from Alejandro, okay? So here's Angel. I like this one. And this is one that we already looked at, but this one...
The answer for this one, what would it be?
Which one are we talking about?
The one you just did.
Oh, yeah, well, it just asked me to list the possible rational roots and then factor with it, right? Okay, so let's keep going. Sorry, you're right. So f of x is now x minus 1/7, right? Times 7x squared plus 7, right? That's my depressed equation, right? And I can factor a 7 out of that. And I get x squared plus 1. And the rest of these roots are complex. Obviously, you see that the cubic goes through only one root. And it's got to be at an odd multiplicity, right? Because it goes through. So I'm kind of thinking, all right, it's either a multiplicity of 3, but it's not. It's a multiplicity of 1, right? Because I still have an x squared term. And there's two roots for an x squared term, but it turns out that these, right, x squared plus 1 equals 0 gives me what? X squared equals -1, which gives me x equals plus or minus square root of -1, which is the complex number I, right? And we're not dealing with complex roots in our class. Since we're not dealing with them in calculus, we're not going to bother with them in pre-calculus. So these guys are complex roots. So we're done with the factoring. That's it.
Okay.
I'm not planning on putting complex roots at all on your exam. No complex roots on your exam. Nice. So on this next one, we have an oblique, right? So find the oblique asymptote. Find the oblique asymptote if it exists. So I have x cubed minus 1 over x squared minus 81. So there's our standard form. My factored form turns out to be x minus 1 times x squared plus x plus 1 all over x plus 9, x minus 9. I did one like this before with synthetic, right? So I would synthetic with 1 and then get the depressed equation to find this other factor here in blue, right? I've got it memorized, so I'd rather you show me that you can do it by synthetic than just write it down. Does anybody want to see that synthetic again? Sean, front and back of a single 8.5 by 11 piece of paper. That's what you can use. And so that one front and back is all semester, even the final exam. Okay. So you're going to have to either start to squeeze things on there or start to memorize things. Like I said, I would do 12 pages. Scan it as a PDF, print it with 6 pages per side. So this one doesn't reduce, so I can see that there's going to be an oblique, right? I can see that f of x kind of behaves like x cubed over x squared, so it behaves like x as x goes to infinity, right? So there's going to be some slant asymptote here. And it might be shifted a little bit, right? It might be x plus 1, it might be x minus 2, right? Still, in the long run, that still becomes x, right? So, but we could find this with long division. So let's do that. X squared minus 81, long divide into x cubed plus 0x squared plus 0x minus 1. So everybody with me here? Angel, you with me here?
Yeah, so far so good.
Yeah. So remember we got to put those placeholders in, right? Placeholders in for every power of that polynomial. So now I'm just asking x times what will get me x cubed, and that's x, right? X times x will get x squared times x will get me x cubed, and then I come back and multiply to everything, right? So I get x cubed minus 81x. I change my signs and add. The first term goes away. We get rid of this process when we do synthetic by bringing down that first term. And so what do I get? I get 81x minus 1, and I'm done, right? Because x squared doesn't go into 81x. So there's my oblique. So y equals x is the oblique on this. Right, so if I'm doing a quick sketch, there's my y equals x. 3, 6, 9, 3, 6, 9. These are my, right? And at 9, it looks like 1 over x. So I'm going to have something like this and something like this. I don't know what's happening over there. Oh, I got 0, 0 again, right? It's doing something like this, I think.
Sorry, could you explain? So what happens with the remainders?
Oh, I don't care. Because when I get out to infinity, I don't care about pennies. I don't even care about $100 bills. In fact, I don't even...
Oh, okay.
Yeah.
Okay, so the... what's it called? The answer is just x? Y
Yeah,
equals
yeah,
x.
yeah. It's your quotient, and then forget about the remainder.
Okay.
Alejandro asked, can you find a point on the oblique? Well, there is one. It's 0, 0. That's the only one there is. I can see it right now. So I already found that 0, 0 was the x and y intercept, and it goes through the oblique. So there's not much work to do. I'm not going to ask you for that. Alejandro, that's like the second time you brought that up, but I don't. Is it asking you for a point on the oblique in the homework?
Yeah, it is.
It should always be that obvious. It'll always be that obvious.
So the oblique is always 0, 0?
No.
Oh,
The oblique
okay.
is whatever I get from my quotient.
Okay.
And then a point on it will be obvious, but I'm not going to ask you for that on the test.
Oh, so there won't be no obliques on the test?
I don't have an oblique. I made the test. I didn't put an oblique on.
Oh, okay. Okay.
I thought it was enough for you to do it in the homework, not to have to test on it.
Thank you.
Mm-hmm. Okay, next one comes from Michelle. Nice. So I'm putting a rational inequality on the test. This is a polynomial inequality, but that's fine. So we want to solve this inequality using a sign table, right? So I've got 3x squared, 3 times x squared minus 1 is going to be greater than 2 times x minus 1 quantity squared plus x squared. And so if you remember, I want to solve for 0. So I'm going to move everything to the left. And it looks like I probably should have done everything to the right. So let me do that. I want my leading coefficient to be positive. So I'm going to say 0 is going to be greater than 2 times x minus 1 quantity squared plus x squared minus 3 times x squared minus 1. And so I want to solve for 0 and I want to factor completely. So I'm going to get rid of all of these parentheses. Michelle, this okay so far?
Yes.
Yeah. So 2 times x squared minus 2x plus 1 plus x squared minus 3x squared plus 3. So 2x squared minus 4x plus 2 plus x squared minus 3x squared plus 3. Again, I'm just trying to factor. So I want to try and get this thing completely factored. So it looks like I have 3x. Oh, no, I have, what is this? 2x squared plus x squared minus 3x squared is gone. This one's way too easy. So I have 5 minus 4x, right? And that's it. So I have just one factor and one critical value. My critical value is what? 4/5? No, 5/4. So x equals 5 over 4 is the critical value. Right? And so I'm going to create my sine table from minus infinity to 5/4 to infinity, and I'm going to use empty parens there because I can't get to it. Zero's got to be bigger than that, right? It can't be equal to it. And so now I'm going to create my columns here and my rows. I only have one factor, so 5 minus 4x, right? And I'm going to put in
Shouldn't it be minus 5/4?
positive. Positive.
I mean, because x equals 5/4, shouldn't it be x equals minus 5/4?
So what number would I plug in here to get a 0? Is my critical value, right?
Oh.
Wherever the numerator is 0, wherever the denominator is 0.
Okay, I thought you were solving for x.
Yeah, so 0 and 2 will be good for my tests. When I plug in 0, I get a positive. When I plug in 2, I get a negative. And I want 0 to be greater than, right? I want 0 to be greater than, so I need the negative answer. So the answer is 5/4 to infinity. Look at the ones I did in class. That's more like the one that would be on your test. You'll have several critical values, right? It'll be an inequality, a rational inequality. But I know.
Can you go back to how you get the 5/4 infinity, please?
Yes, so remember, I'm asking for 0 to be greater than 5 minus 4x, right? So that means the answer has to be negative. So where I got my negatives from, I grabbed that interval.
Gotcha.
And so I know what the weird part was here is, well, how do I start? And that's the key is solve for 0. Get everything on one side, and then do some algebra. Get it down to a factored form.
Okay, thank you.
Nice.
You just did the inequalities, right?
Yeah, so I started with this inequality, right? And I kept it true the whole time. So when I got to my simplified inequality, if I solved that one, I solved the original one.
Okay.
I mean, what's nice is to test and see if it works, right? So look, I got 3 times x squared minus 1 greater than 2 times x minus 1 squared plus x squared. And I remember, what was my test value? 2. Let's see if it's true, right? So 3 times 4 minus 1 should be greater than 2 times 2 minus 1 quantity squared plus 2 squared. I'm question mark, right? I'm seeing if my test value that showed me in my sine table where the answer was, if it works, right? So what 3 times 3 should be greater than 2 times 1 squared plus 4. 9 is greater than 6 is true. Done. Right? When I ask you for a difference quotient on the test on Friday, I want you to test the difference quotient. What does that mean? Find a slope the way you did it in 8th grade. Verify that the slope works with the difference quotient. Right?
Professor, I have a question.
Yes, Grace.
Can we just go back up to that part where we ended up with 0 is greater than 5 minus 4x?
Yes.
Why did it come to 5/4 instead of 4/5?
Good. So I'm trying to set every numerator equal to 0, right? So I get 5 equals 4x, so I get x equals 5/4. Set every numerator equal to 0, every denominator equal to 0, and those are your critical values. Yes? Grace?
Okay, so okay, I get it. Thank you.
Yep. Set all your numerators equal to 0, set all your denominators equal to 0, and you're going to be doing stuff like this all in calc. When you do something called a first derivative test, when you do something called a second derivative test, when you do optimization, you're going to be doing this process, right? So this process will be happening over and over again in the next couple of semesters. All right, cool. And now Alejandra, right? Nice. So do the graph of, yep, cool. So this is another one like we had earlier, but that's fine. I don't mind doing that at all. 3 over x squared minus 25. There's my standard form. In the calculator, I'm doing 3 divided by parenthesis x squared minus 25. Right? Multi-terms have to get wrapped in parens. My factored form is going to come in the right. I know how to factor that x squared minus 25. That's an x plus 5 and an x minus 5. Nothing reduces, so this is also my reduced form. So this is just the factored form. Nothing reduces. What's my domain? X does not equal plus or minus 5, right? What's the horizontal asymptote? F of x is approximately 3 over x squared as x goes to infinity, right? So that's y equals 0, right? So 3 divided by 1,000,000,000 is really small. So y equals 0 is the HA. And if you remember, I was saying when the denominator dominates, we're going to have a horizontal asymptote of 0, right? When the numerator dominates, it's going to be an oblique or a quadratic or a cubic, etc. When the numerator and denominator are of the same power, we're going to get the ratio of the leading coefficients. Where are my vertical asymptotes? At x equals plus or minus 5, right? What are my intercepts? Well, I can't, the numerator is never 0, but I can let x be 0, so I get 0, negative 3/25. I'm ready to kind of start. I probably want to do a short run, but I'm going to cheat. I'm going to graph this whole thing on the calculator, right? So at x equals 0, I have my, at y equals 0, I have my horizontal asymptote. At plus and minus 5, I have a vertical asymptote. Oops. I have the point 0, negative 3/25. So I want to kind of look at short run. So short run at 5 gives me a 1 over x look. So f at 5 kind of looks like 1 over x. F at negative 5 looks like negative 1 over x. So
wait, quick question. So
yep.
you don't plug in the 5, right? Because that would create.
So I'm looking at this version, right? F of x is 3 over x plus 5 times x minus 5. And so I'm saying f of 5 kind of looks like 3 over 10 times x minus 5. So there's my 1 over x. You can see 3/10 times a 1 over x.
Okay. Got it.
But again, you're going to graph it. So you're just trying to show, algebra to verify what the graph is already telling you. So you're just trying to fake me out as much as you can on the test. Show me as much algebra as you can, right? And pretend you drew the graph. And label it.
All right.
Right. Yeah, honestly.
Okay, got it.
What was that rule you said about the horizontal asymptote if the numerator
when the denominator's bigger, the power in the denominator's bigger, right? You're gonna have something over an x. Right? So that's gonna be a horizontal asymptote of 0. When the powers are the same, you're gonna have some ratio of coefficients. So like y equals 1. And then when the numerator's bigger, it's going to be an oblique or worse.
Okay, thank you.
Yeah, but you don't have to think about that. Just do this long run behavior thing and then figure out what happens, right? And you can see in the long run, I get something like 3 over x squared, and 1 over x squared looks like this. And do you see that on our graph at all? Do you see that shape on our graph at all?
Yeah. The top part.
Exactly.
Right?
Exactly. And why is it getting pushed? Why is it pushed apart? Because of where the vertical asymptotes are, right?
Okay.
And so something else is happening in between the vertical asymptotes. Alejandro, did that help? It's okay?
Yeah, thank you.
Nice. Well, guess what? We're done. If that's it, if that's all you want me to
All right,
answer.
thanks, Professor.
What's that, Rafat?
I said thanks, Professor.
Okay, you got it.
Wait, are you serious? We're like done?
Yeah, if no one else has questions, I don't.
I have another one.
Okay, good. Oh, damn it. Who just left? Let me take attendance real quick. Was it Daniel? No, Daniel's still here. Somebody just left. 4, 8, 12, 16, 20. I'm missing 3 students? What the hell? Go ahead, Diego. Are you sending me one?
It's in the same email I sent you.
Oh, okay.
The other one.
Okay, good. Let me look.
It's the last one. The
No
one
problem.
that's on like paper.
No problem. Let me see. Oh, you're right. I didn't see the others. Sorry about that. Which ones? Real zeros?
Yeah, the one that's on paper.
Oh, the one that's on paper. Nice.
Because I started doing it, but then I got stuck, and I don't know.
Okay, I'm sorry. I lost. I just got an email from my big boss. Diego, one on paper. Here it is. Nice. So I have, and will you just read me that function? F of x is 9.
9x to the power of 4.
Yep.
Plus 28x cubed.
Yep.
Plus 66x squared. Plus 196x plus 21.
Horrible. That's horrible. Horrible problem. Who the hell would assign something like that? So you found a zero of what? 3?
Yeah.
Of negative 3. Nice. So we just start chipping away, right? So I definitely would want to graph this, right? But since you already did the start of the work for me, you already found me a 0 of negative 3. I'm gonna synthetic divide with that. No problem, Vanessa. Don't worry. Let me take just attendance real quick again. So everybody's set for Friday, right? We have no worries about doing anything, about sending a PDF, about using the lockdown browser. Everybody's set to go. So let's see, negative 27, 1, negative 3, 63. Help me here. 189.
Negative 189.
Yeah,
and
7, negative 21. Nice, nice. Cool. So I see that f of x is now...
Sorry, Professor, quick question.
Yes.
Where did the negative 3 come from? Is that a factor?
Diego had probably looked at the graph and saw that it cut through negative 3.
Oh, got it.
Yeah. So x equals minus 3 is a 0, or x plus 3 is a factor. Right? So now I have f of x is x plus 3 times that depressed equation, which is 9x cubed plus x squared plus 63x plus 7. And for that one, I actually see I can factor this without doing any work at all. So I can see that this thing factors into... I can take out an x squared here, I get 9x plus 1. And I can take out a 7 here, I get 9x plus 1. So I can see that I got x plus 3 times a 9x plus 1 times an x squared plus 7. And I'm done. There's my piece. So now I would have seen another 0 at negative 1/9. I would have seen another 0 at negative 1/9. Right? So my graph is looking something like this. 1, 2, 3. So it goes through negative 3. It goes through negative 1/9. Wait a minute. Oh yeah, it's a cubic. It's a quartic. So it's just doing something like this. Right? It's the mother function is x to the 4th. So it starts up, ends up. Alan asks how many questions on the test. It's going to be an hour and 25-minute test. So no matter how I write it out, right now my plan is 5 questions, but everything has like a zillion parts, right? So I would imagine 5 questions might take you 15 pages. So make sure you have that paper ready, right? Four, 8, 12, 16, 19. I'm actually missing 4 students. I don't get it. 4 students missing. What else? Anything else?
I think we're good, Professor.
Nice.